Alright, this is another MCA lesson for 7th grade, and today we're talking about solving multi-step equations. And this is something that came up on the MCAs, and we've hit it a little bit, but once again, want to hit it a little harder before we go in and take the MCAs again. So, we're going to cover it a couple days before. We'll work on this again tomorrow, but we started with it today. And this is basically what it looks like. We're going to go through 3 examples together. Alright? The big thing about solving for a multi-step equation is we want to get x, or whatever variable we have by itself. We want to isolate the variable. So how is this different from what we've been doing? Well, we've been doing single-step equations. That would look like 5x equals 25. This is a one-step equation because we only have one step to get the answer. 5 times what gets us to 25? Well, we know that 5 times 5 gets us to 25. How do we show that? We didn't know what that 5 times 5 got us to 25. We could do the opposite or the inverse of what is happening to our variable. So let's look at our variable x. What's being done to it? Well, we're multiplying it by a 5. So the thing that we want to do is the opposite or the inverse of that, which is divide by a 5. But whatever we do to one side, we have to do to the other. And we would be able to see that 5 divided by 5 is 1. 1x. You don't have to have the 1 there. We've talked about that before, but that's okay. We've now singled x out. We only have 1x. I'm going to leave it just as x. And 25 divided by 5 is 5. And that's how we would do that. Now, why do we have to do one? If we do one thing to one side, why do we have to do it to the other? Well, that's a good question to ask or consider. So let's use this 2-step equation, keeping our inverses in mind. We're going to be doing inverses to solve for x here. And why do we have to do whatever we do to one side, why do we have to do it to the other? Well, first thing that I like to do is draw a line down between the equal signs. So we have 2 sides. We have the right side and we have the left side. Alright? And think of a scale. Like in science, something like that. You'd have a scale and it's balanced. Well, right now, this equation is in balance. Negative 2x minus 5 and 9. Alright? They are balanced with each other. Both sides are in equal balance. Now, this is why when we do one thing to one side, we have to do it to the other. Let's say we were going to add 3 pounds to this side. What would happen to this side if we didn't add 3 pounds to it? Well, this would come down because it would be heavier, and this would go up because it would be lighter. So, if we decide to add 3 pounds to this side, we have to add 3 pounds to this side to keep them in balance. This equal sign tells me that they are in balance. So we have to keep the equality on this side and this side in order to find x. So that's the whole reason we do that. So that's just a visual, the scale. We don't need to use that all the time, but that's how I like to think about it. Now let's get into the inverses of all this. How are we going to get x by itself? Well, I like to cover this up, and I like to see, first of all, what's happening to this term right here. Yeah, you need something? What's up? Oh, recycling? Alright, sounds good. Thank you. First of all, we want to look at what is happening to the term that has the x with it. So that would be a negative 2x. We want to get rid of this minus 5 first. Alright? So in order to get rid of the minus 5, we have to do the inverse of that, and that would be to add a 5. And you'll see why I'm doing that in a second. The opposite of a minus 5 is a plus 5. But whatever we add here, we have to add over here to keep it balanced. So that's our first step. Alright? Draw a line. And if we do a minus 5 and a plus 5, together, we get 0, or they cancel each other out. So what I like to do is just say that those two cancel out with each other, and then there's nothing left. Remember, if we add 0 to something, it doesn't change what we're adding to, right? That's one of our properties, the additive identity. If you add 0 to something, it's not going to change it. So adding 0 to a negative 2x doesn't change it at all. It stays as a negative 2x. I could put plus 0 if I wanted to, but what's the point? It's not going to affect anything. So we could just say that these two things cancel out. And now we're left with just this negative 2x over here, but now we have a 9 plus 5 over here, and 9 plus 5 is 14. So now, that was the first step of our equation. We are now one step away from solving this whole thing. So we have negative 2 times x equals 14. Now we get into some negatives and positives and all that stuff. We can't forget our rules when working with those negatives. Since x is being multiplied by a negative 2, we're going to do the opposite or the inverse of that, which would be to divide by a negative 2. Do not neglect the sign in front of it, okay? We have to divide by negative 2. Alright, so we go ahead and do this. I like to section these things off. We should get our answer here. Alright, negative 2 divided by negative 2 is just 1. They cancel out with each other. So we're left with 1x, or just x. And 14 divided by negative 2 is negative 7. So that would be our answer there. Okay? Now, we can actually check this answer, once we get it, by reinserting negative 7 into the original equation. So let's do that, just to see if we got it right. Negative 2 times x, which is, we say is negative 7. So we got negative 2 times negative 7 minus 5. We'll see if we get 9. Negative 2 times negative 7 is a positive 14. Two negatives together multiplied gives us a positive. 14 minus 5 is 9. So we know we got the right answer. X equals negative 7. Alright. Let's take a look at another one. Not that one. We're not ready for that yet. But we will get to those. Alright, this one's pretty easy. Now, one thing that you can do, if they do give you options for what x is, you can actually just try each one of these, like we just did to check our answer on the last one. Put 13 in for x and see if it comes out to 61. Put 12 in there and see if it comes out to 61. Alright, I'm going to tell you right now that the answer is number 2, x equals 12. Because 5 times 12 is 60, plus 1 is 61. Now how do we show that? In case they don't give us choices, or in case we just want to make sure that we're correct. Alright, so we want to get this term by itself first. We're adding a 1, so we want to do the inverse of that. And subtract 1 from both sides. So we're keeping our equation balanced. Positive 1 and a negative 1, they cancel out. So we're left with a 5x over here. And that equals 61 minus 1, which is 60. And now our last step, we want to do the opposite of what's happening to our x there. We're timesing by 5 or multiplying by 5, so we do the opposite of that, or the inverse. And we got to divide by 5 on both sides. 5 divided by 5 is 1. You're left with 1x. And that equals 60 divided by 5, which is 12. And we already know that that's the right answer. Okay? So if they give you choices, go ahead and plug x in right away, and or plug those numbers in for x and see which one gives you the right answer. But if they don't give you options, you can go ahead and do it that way. See if we have time for one more. We do have time for one more, and this will be a good one because it's got some negatives involved. Let's check this out, see what we get here. Always want to do that first. And we want to get that 8x term by itself so that eventually we can get x by itself. So typically what you should notice is we're either going to add or subtract as a first step usually. and almost all the time we are going to be doing a division step on the last part. That's typically how it works with two-step equations, so just be aware of that. Things will change a little bit as we go on, but for now that's kind of what it is. And later on in your math careers, you get it down into this form, so that will be your last two steps usually. So there will be some stuff added on, we'll get to that later. Typically when you get to this point, or if an equation looks like this, you're going to either add or subtract first, and then divide, okay? Alright, so anyway, cover this up. We are minusing a 3, so we want to do the opposite or the inverse of that, which would be to add a 3. So let's do that. Plus 3. And let's plus 3 over here too. Now we know that minus 3 or negative 3 plus a 3 or minus and a positive will cancel out with each other, especially, well, they will cancel out with each other if they are the same number, or basically they are opposites. Sorry, got tripped up on my words there. Alright, so a negative 3 and a positive 3, we know those will cancel out. Add them together, you get 0. So they cancel with each other. And you're left with 8x over here. We also have to do that negative 27 plus 3. And this is where we can't forget what our negatives are like when we add with negatives and positives, or negatives and negatives, or whatever they give us to work with. So we want to think, okay, we're at negative 27 degrees, and we're going to get 3 degrees warmer, okay? So 3 degrees warmer than negative 27 would be 24. But we have more negative than we have positive, so we should have a negative answer. Another way you can do that is 27 minus 3, and then realize that we do have more negative than we do have positive, so it will be a negative. So negative 24. Alright? We are now one step away again. We have 8 times what gets us to negative 24. And we want to do the opposite of 8 times x, so we're going to divide by 8 on both sides. And we should get our answer now. 8 divided by 8 is 1, so we have 1x left. And negative 24 divided by 8, well, 24 divided by 8 is 3, so negative 24 divided by 8 is negative 3. And that should be our answer. That's our first choice right there. Alright, so there's 3 examples of that. We're going to cover this more tomorrow, but wanted to get it out there for everyone to see it. Thanks.